So we're working on the Exam 1 review for Math 1813, which is preparation for calculus. So this says I have three functions, f, g, and h, and if you look at these, it looks like the function f is given in terms of a table, the function g has a formula, and the function h just has a graph. So the first thing I want to do is I want to find f of 5. So to find f of 5, I'm going to look at the function f that's right here, and I can see the x value 5. For the x value 5, the input is 7. So f of 5 is equal to 7. Now I want to find h of 1. So if I want to find h of 1, I'm going to go over here to the graph of h. And h of negative 1. So negative 1 would be an x value. So I look at h of at x equal negative 1, and I go up to the h value. It looks like it's at about 4. Next, I want to find g of 3a. So what that means is I'm going to plug in 3a in place of x for the function g. So g of 3a will be 1 minus 3 times 3a minus 2 times 3a squared. And so then I can just simplify that, and that will give me my value. So I'll have 1 minus 9a minus, let's see, 3 squared is 9 times 2 is 18a squared. So that's my final answer for that. So 1 minus 9a minus 18a squared. Next, I want to solve this equation, h of x equals 0. So I want to look at the function h, and I want to find the x value when y is 0. So I'm looking for an x coordinate when the y coordinate is 0. So if I go over here, when the y coordinate is 0, that will be on the x-axis. So here and here are the two places where the y coordinate is 0. So I actually have two solutions, x equals negative 3 and x equal 1. The next one I want to solve the equation g of x equals 1. So I'm looking for an x value in the function g. I'm looking for an x value when the outcome is 1. So if I look at this, I can see that it works when x is 0. So let's go ahead and set up this equation. And I might need to do some quadratic. So if I set g of x equal to 1, that means 1 minus 3x minus 2x squared equals 1. So let's get everything all onto one side. So if I move everything to the right, I'll have 0 equals 2x squared plus 3x, and then when I subtract the 1 over, I get that there's nothing there. Now I can factor out any common factors. So I'll have x as a common factor, and I'll have 2x plus 3. And so this gives me actually two equations, x equals 0 or x equal 2, x equals 0 or 0 equals 2x plus 3. 0 equals x, or 0 equals 2x plus 3. And so if 0 equals 2x plus 3, then that means x is equal to, I could subtract the 3 over, divide by 2, negative 3 over 2, or 0. So those are my two solutions, x equals 0 and x equals negative 3 halves.
Okay, so we're looking at number 2 here. So we're given this function here, and we're given these two values, and we're being asked to find the exact value of b. So the first thing that we're going to do is go ahead and take this negative 3 and 7 and go ahead and plug them in. And remember, we plug the negative 3 in for x, and the 7 is what we plug in for p of x, or on the opposite side of the equation. So we're going to have 7 equals negative 2 times negative 3 squared plus negative 3 times b plus 5. So now we can go ahead and take this negative 2 times negative 3 squared and rewrite that. So negative 3 times negative 3 is 9 times negative 2 is negative 18. And this is going to be minus 3b plus 5. So negative 18 plus 5, that gets us negative 13. So we have 7 equals negative 13 minus 3b. So Now we can go ahead and move this 13 over to the opposite side. We get 20 equals negative 3b. And then lastly, divide by negative 3. And we wind up with b equals negative 20 over 3. Okay, so looking at 3a here, we're given this function here, and we find and simplify f of negative 2. So to do that, we take negative 2 and plug it in wherever we see x into our function, which means that we're going to have 3 times negative 2 minus 1 squared. So this is the same thing as 3 times negative 3 squared, or 3 times 9, which is just the same thing as 27. Then next, looking at part B, we have negative 2 plus h. So the only difference here is wherever we see x, we're going to put negative 2 plus h. So we're going to have 3 times negative 2 plus h minus 1 squared. This is the same thing as 3 times negative 3 plus h squared. So whenever we square this, we have to FOIL it. So we're going to have negative 3 plus h times negative 3 plus h. So first we do our first terms. So we're going to have 9, and then negative 3 times h, and then h times negative 3. Then we have h times h, or h squared. So these two middle terms we can combine to get negative 6h. Then we multiply by 3, so we're going to have 3 times 9 is 27. And then we're going to have negative 6 times 3, or minus 18h, and then plus 3h squared. So that's what this equals here. Okay, and then looking at this last part here, notice how this top part right here, is the exact same part as we have in B. So we can kind of use the previous parts that we've done to help speed this up. So this negative 2, f of negative 2 plus h is what we did in part B. So we're going to have 27 minus 18h plus 3h squared. And then minus f of negative 2 is what we did in A. So we just get minus 27. This is all divided by h. So if we combine our like terms in the numerator, we can cancel out the 27, and we're left with 3h squared minus 18h divided by h. And then we can cancel out our h's, and we are left with 3h minus 18. And that is our answer there.
Okay, so number 4a, it's asking us for the function f of x equals the square root of x minus a, where a is a real number. Find each of the following. A, what is the set of all input values for this function? Use interval notation. Okay, so what we need to think about is our function f of x, square root of x minus a. And so it's asking us, what is the set of input values for this function? Okay, so what do we know about square roots? We know that there cannot be a negative number under the square root. So we're going to use that to help us find all of our input values. So remember, x is our input values. So we want to say that, x minus a has to be greater than or equal to 0, right? Because if it was less than 0, it would be a negative number, and that's going to be a little bit of a problem. Okay, so now we want to solve for x to find those input values. So we're going to say plus a on both sides. We're going to say x has to be greater than or equal to a. Awesome. Now writing that in interval notation. So remember, interval notation is going to include like some parentheses and some infinities. So we know that x has to be greater than a. If we were to draw a number line, right, and we have some point A right here, we're saying that x has to be greater than a. So x is going to be on this side of a. Everything up until infinity. And it says we have this equal sign. So we can include a, has to be greater than or equal to a. So we're going to have that little bracket right here. So when we write this in interval notation, we're going to get bracket a, comma, infinity, close or parentheses. So yeah, so that is going to be the answer to part A. Okay, so part B. It's asking us what the set of all the output values are going to be. So remember from the last section, the set of input values are a, comma, infinity. So what we want to check when we find our output values is what happens at kind of the endpoints of this input values. So our function being f of x is equal to the square root of x minus a. Let's figure out what happens at a, and then let's figure out what happens at infinity. Okay, so let's think about a. If we were to plug in a into this function, we have f of a is equal to the square root of a minus a. Okay, so that's going to be what? The square root of 0, which is just equal to 0. Okay, so we know that that happens at 0. And that's kind of the lowest number we're going to see, right? Because that's our lowest input value. Okay, well, let's make sure that's true. Let's check our output value. Okay, so we have f of, you can't actually plug in infinity, but let's just think about it. If we were to plug in infinity into this function, we would get equals the square root of infinity minus a. Okay, well, that's going to be a really big number, so we can just, safe to assume that we have the square root of infinity. And the square root of infinity is going to be really, really big, right? Let's think about the square roots we know. Like the square root of 100 is equal to 10, right? And the square root of 25 is equal to 5. So as our square, something under the radical is getting bigger and bigger and bigger, our output value is getting bigger and bigger and bigger. So what we can assume with this is that our output values are going to match. So we're going to say our output value, we said our lowest value is going to be 0. We can include 0, we just found it. And then our highest number is going to be infinity. It's just going to grow indefinitely. Okay, so this next question, 5a, is asking us if the graph of a is a function or not. So remember back, way back when we talked about our vertical line test. This is going to test if our function is a function, right? So I want you to imagine dragging your pencil from the left to the right of this function, and we want to see if your pencil touches 2 points at the same time. As we do that, we see that it does not touch 2 points at the same time, which means this is a function. Yay! So now we want to find the domain of this function. So again, we're going to start with the left, and remember, domain comes from our x-axis, right there, right? So we want to see those are the values we're going to find for our domain. So starting on the left, we see right here, that means our function is going down indefinitely. So we're going to start over here at negative infinity. And remember, if we have an infinity, we're always going to have a parentheses and not a bracket. So as we go to negative infinity, we're going to go up and up and up and up and up, and then we see this spot, -4. And so we see that this spot, -4, is included. Way up here, that dot right there means it's included. So it is included. So we're just going to keep going along of our x-axis. We're going to get -2, all of that stuff. Then we get to the spot 2. It's also included at 2, which is important, but we need to stop there. So we need to put a comma, we need to put 2, and we're going to use a bracket because it is included. That circle is filled in. And then we have a little bit of a jump. We have a jump to 4, so we need to put our union, right? And then we're going to have our bracket again because it's included at 4. We're going to say 4. And then we're going to follow our line, and we're going to go all the way to 8. And then see we have an open circle here. That means it is not included at 8, so we need to put our 8 and then a close parentheses. So now we're working on range, which remember, range is going to be our y-axis. So we want to start looking down here. We're going to see this starts at way down here at negative infinity. So we're going to say our range starts at negative infinity. And then we look as if we're going from negative infinity. We're rising, we're rising, we're rising, following that y-axis, and we bump into this open circle at -2. And then we want to double check on any other part of this graph if we have a spot at -2. And we see over here we also have one here, but it's also open. That means so -2 is not included on our graph. So we're going to say -2 with an open bracket. But since this line cuts down all the way to -2 with an open bracket, we know that the points right before -2 and right after -2 are included. So we're going to have that union and -2 on this side. So now we're going to keep rising with our graph. We just stopped at -2. We're going to rise, 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 rise. And then we stop here at +1. So we see some dots here at +1, and we see a whole line, which means all of those points are included, and +1 is included. So we're going to drop our 1 right there and finish it off with a closed bracket because 1 is included. So that is our range. So doing the same thing as on 5B as we did in 5A, we want to check if this graph B is a function or not. So our step 1 is to do that vertical line test. Okay, so remember we're going to drag our pencil, holding our pencil vertical from the left of the graph to the right of the graph. And our first issue we run into is this point and this point. And since both those points are closed, then that's telling us our graph has 2 outputs for 1 input, and that makes it not a function. So it fails the vertical line test. So this would be not a function. And since it's not a function, we don't have to find the domain or range. Okay, so for this next problem, 6A, we're finding the domain of the function. So we need to look at what cannot happen in this function. So for starters, we can't have zeros in our denominators. So that's something to note. And we also can't have a negative under a radical. So knowing all those things, let's start with our first function here, our first part of our function there. And let's make sure we can't have that 0 under our fraction. So how we do that is we say x plus 2.9 cannot be equal to 0, right? So we need to find out when that's equal to 0 and make sure we can't have that x value. So all we have to do is solve for x. So we minus 2.9 from both sides, and we have to say x cannot be equal to negative 2.9. Okay, great. So we're going to hold that up in the corner over here. We're going to say x cannot equal negative 2.9. We're going to erase this and do it with the next part of the function. So our next part of our function, our denominator is x plus 7, so we have to say x plus 7 cannot equal 0. Awesome. So again, we're solving for x, and we're saying x cannot be equal to negative 7. Okay, we're going to hold that up here as well, negative 7, and we're going to erase this part and do our last part. And the last part is a little bit different. It's a radical, so we have this radical x plus 6.4. And remember, we can't have negatives underneath the radical, which means that this under part, the numbers part of our radical, has to be greater than or equal to 0, because we can have a 0, but we can't have a negative. So we write that just like the inequality, x plus 6.4 has to be greater than or equal to 0, okay? And so again, we solve for x. We subtract 6.4, subtract 6.4, and then we say x has to be greater than or equal to negative 6.4. Awesome. Okay, so now we want to use all three things to find our interval notation. Okay, so I'm going to draw a number line to help us out. So we have this number line, and so let's just kind of jot down the things we have. So at negative 7, we have like an open circle here. X cannot be here, okay? And the same thing happens at negative 2.9. We have this open circle here. And then this little inequality here tells us that x has to be greater than negative 6.4. So negative 6.4 is somewhere here, 6.4. And it's saying that x can be included in negative 6.4, but it has to be on this side of the line. So we don't really have to worry about this -7 because the -6.4 already doesn't include that point. So we don't have to worry about that when we're writing our inequality. So now, writing our inequality, using this graph, we have -6.4 is our starting point. So we have our bracket because of this closed circle, -6.4, comma. So we're going and we're going and we're going, and then we have this little halt here at -2.9. It cannot be that, so we need to close that off. So we have -2.9, close parenthesis, union, and we'll pick back up, and we're going to go all the way to infinity. So we have -2.9, comma, infinity. And that will be our domain. Okay, 6b. So we want to be looking at, again, what's going to make this an issue? What's going to make this undefined or not real or something like that? And we see this fraction here, right? Remember, if we have a fraction, we don't want a 0 in the denominator. So how we do that is we take whatever's in the denominator and we set it equal to 0, and we find out when those x's are. So step 1, so we have x squared minus 3x minus 10, and we're going to set that equal to 0. Okay, if we notice this is a quadratic, and we can solve quadratics by factoring, or we can solve quadratics by the quadratic formula. So we need to think, what are two numbers that multiply to -10 and add to -3? So those numbers are going to be -5 and 2, right? -5 times 2 is equal to -10, and -5 plus 2 is equal to -3. You can also use the quadratic formula to find those, but factoring is just a simple way to do it fast. So we can rewrite, by factoring, we can rewrite this quadratic as x minus 5 times x plus 2 equals 0. And then knowing our zero product property, we can set each of these equal to 0 and solve for x. So we can say x minus 5 equals 0 and x plus 2 equals 0. Solving for x on both sides, we can say x is equal to 5 and that x is equal to -2. So these are two spots in our domain that is going to give us a 0 in the denominator. So now we need to write this in interval notation. Again, we want to be using a number line, or at least I think it's helpful to use a number line to visualize it. And we're going to say, okay, here at -2, we have a hole, and here at 5, we have a hole. But our domain is valid everywhere else. So how would we write that in interval notation? We're going to start over here at -infinity. We have -infinity with our parenthesis, and we're going to go all the way to -2. We're going to make that a little hole, union, -2, right? -2 to 5. So we're going to say -2 to 5 because we can't include either of those points. Union again, 5 to infinity. And that will be our domain for part B.
Okay, so we're going to be looking at 7 here, starting with A. We need to match each function to its correct domain and choose only one answer for each function. So whenever we're looking at domain is just our possible x values that we can plug in where we get a real answer. So in most cases, what we want to look out for is either a 0 in our denominator or a negative in a square root. Those are usually the two things that we need to keep our eyes open for the most in this class. So looking here, we have 1 over x plus 1 over x minus 1. So like I said, we need to look out for zeros in our denominator. So where does that occur? Well, if we were to plug in 0 for x, we would get 1 over 0 plus 1 over -1. And we can't have 1 over 0. So we know that x cannot equal 0. And we also know that if we plug 1 in to our denominator, we would also get a 1 over 0. So we would get 1 over 1 plus 1 over 0. So x cannot equal 0 or 1. So it can equal any other number, it just can't equal those two. So how do we write that as a domain? So using our notation, we want to say that we go from negative infinity, we always use parentheses around infinity, to the number that we can't be, which is 0. Then we're going to use this little symbol here, union, and then we go 0 again to the next number, and then we just go to infinity, like that. So remember, parentheses means that it is not included in our set. So if we read this, we're saying that our domain goes from negative infinity to 0, but we don't include 0. Then we go from 0 to 1, not including either of them. And then we go from 1 to infinity, not including either of them. So that's that one there. And so if we look at which one lines up with that, that would be the letter I here. Okay, moving on to part B here. We have 1 over the square root of 1 minus x. So remember, we can't have a negative in a square root, and we can't have a number over 0. So let's first look for whenever we have a number over 0. So if we have 1 over square root 1 minus x, and we're worried about getting a 0 in our denominator, we can kind of just focus on looking at it like this. See when that 0 occurs. So if we do something like this, we can see that whenever x is 1, we get a 0, which would mean that we have 1 over 0, which we don't want. So in this case, we can go ahead and say x cannot equal 1. Okay? Now the next component. We know that we can't have a negative in a square root. Okay? So we're interested in whenever the square root of 1 minus x is going to be, well, positive on the inside, right? So what we can think about is 1 minus x being greater than or equal to 0. However, because we said earlier that it can't be 0, really, we can just say greater than 1 minus x is greater than 0. So if we look at this, we can see that, okay, well, it's whenever x is less than 1, like that. So that means anything like negative 10 would work. If we go back to our original and we plug something like that in, we would get 1 over square root of 1 minus a negative, which would be a positive. So we know that these are our two conditions here that we need to follow. So now we just need to write this as a domain. So we can say that, well, x has to be greater than 1 and it cannot equal it, right? Or excuse me, has to be less than 1 and it cannot equal 1. So we can say that our domain has to go from negative infinity to 1 and does not include either of them, so we use parentheses. So which one lines up with that? That is B over here. Okay, so we're moving on to part C here. We have the square root of x plus 1 over 2x minus 2. So the two things we look for is 0 in the denominator. So we can find that by saying 2x minus 2 cannot equal 0. So 2x can equal 2, x cannot equal 1. So if we plug 1 into our original function, we're going to get a 0 in the denominator, which we don't want. The next thing is to look for when we get negatives in our square root. So we can do that by saying x plus 1 must be greater than 0, right? Or equal to. So if we do this, we can see that x has to be greater than or equal to negative 1. Okay, so now we just need to write these conditions in our interval notation. So starting with our smallest number here, this negative 1, we need to be greater than it, or we can be equal to it. Because if we get negative 1, we're just going to have square root of 0, which is 0. So we go from negative 1 to our next number that we don't have, which is 1. We write it using this here with union. We go 1 to infinity, close parentheses. So which one of these lines up with that? That would be M. Okay, moving on to number 8, we have the monthly charge for water depends on your usage. For a customer using no more than 20,000 gallons of water in a month, the charge in dollars is given by that function here. When X is gallons of water are used, what are the domains and range of this function? So our domain is how many gallons of water we can use. So we can't use a negative amount of gallons, right? And we can't use more than 20,000. So we can say that we're gonna, our domain is gonna be 0 to 20,000. Okay. Next we want our range. So if we look at this function here, we notice that it is linear and it also has a positive slope. So that means we should expect it to be a fairly, something like a nice straight line. And we should expect our minimum to be at our lowest x value and our highest x value would be our maximum. So using that, we can go ahead and just plug in our two values that we have. So if we plug in 0 for x, we would get c of 0 equals 0 plus 15, which is 15. And then if we plug in 20,000, we would get 0.004 times 20,000 plus 15. And this should work out to be 95, which means that our range, and it's going to be inclusive because we included that 0 for whenever we found the 15 and as well as the 20,000 to find the next number, which was 95, which means that our range is going to be 15 to 95. We're going to use brackets because we're including it. Okay, so for number 9, we need to give an example of a function that has this given domain. So if we notice, I think the easiest place to start is with these here, these two little gaps. So those are because we are getting a 0 in our denominator at x equals -1 and x equals 5. So in that case, we should expect our function, whatever it is, to be something, and then we're going to have over x plus 1 and x minus 5. So this way, if we plug in a -1, we can see that we get 0 in our denominator, which means that our function does not exist and is not included in our domain. The next thing that we can look at is taking care of this. So all of this is saying is that numbers less than -6 are not included, right? But we can include -6. So this is probably because of a square root. So how can we include this? Well, if we can have any number that's greater than -6, except for -1 and 5, we can go ahead and assume that x is probably just going to be positive, and that we're going to have a plus 6. So that way it works out. So that way if we plug in -6, our square root is 0, but we could also plug in 0 or something, and we would get a real number. So our final answer for our function is going to be square root x plus 6 over x plus 1 times x minus 5. Okay, so on number 10, we're trying to find the domain of g of x given a is greater than 0 and b is greater than a. Write your answers in interval notation. So if we look here at what our domain can't include, remember, no zeros in our denominator, no negatives in square root. So we know that x minus b cannot equal 0. So whenever we look at our domain, we should expect a gap or a hole at x equals b, which means that we should have something kind of like this here. So we also can notice that x can go all the way to infinity with nothing happening, right? We're not going to get a negative in the square root if we go to a really large number. So we can go ahead and assume that this goes to infinity. So now we just need to look at this left side here. So if we notice, if we had x minus a and we plugged in a for x, we would get square root of 0, which is perfectly fine. But if we had something less than a, we would get a negative number, which is not included in our domain. So we can go ahead and say that a can be on this side here. We're going to use brackets because we can't include it, right? It can equal a, it just can't be anything less than a. So this satisfies both of our conditions here. And notice the b is greater than a. That sort of shows up in the fact that our b is after a on our number line kind of here, if we were to look at this as like a number line, right? Where this is a and then we have b occurring here and we'd go towards infinity. So that's kind of why we're saying that b is greater than a. So this is our answer here. We get bracket a to b, parentheses, union, parentheses, b to infinity, parentheses. Okay, so on number 11 here, we're looking for the domain here, where x is greater than a, and a is greater than b, write your answer in interval notation. So if a is greater than b, we kind of end up with the opposite of what we got previously on number 10, where if we were to look at because it's almost the exact same, or it's the exact same function, we've just changed what a and b are. So if we look at before, we said that we would have something kind of like this, where we had a and b. So b occurred after a in the number line. So now we're doing something kind of like this, where we're going to have b over here. So since this portion here is all that we care about for our domain, b isn't actually going to be in our domain whenever we write it in interval notation. So what we can expect for our answer is bracket a to infinity, parentheses. And again, that's because b is less than a, but we also can't include numbers less than a because that would screw up this here. Oops. So that's why that is written this way.